In this video, we're going to introduce UCINET and inspect some network files for the first time. So after installing UCINET, the first thing I would do is create a new folder to store the data in, because UCINET produces quite a lot of files when you want to analyse with it. So we've put our data set that we're going to look at today, dolphins, in there. Then if you open UCINET, it will tell you that the default directory is something. The first thing you should do is change your default folder to that working directory so that everything happens in the one spot. UCINET itself is a program for running a lot of network analyses, and it links with this button up here to NetDraw, a program for visualizing networks that can also run some analyses in it. So the first thing we're going to do is have a look at our file with the dolphin data in it. And if you look at this, this is in typical edge list format where something is moving from certain nodes to other nodes. And if we just, for a point of reference, look at feather and gallatin, so these are two dolphins, something's happened between 6 times. So if we just highlight all this data by using Control-Shift down and Control-C to copy, then into UCINET, select the data menu, import Excel, DL type formats, and then Control-V just to simply paste in. Up in here, select the format as Edge List Ego Alter, tick the column headings box, and push the Save button. Name this dataset Dolphins Asym to designate that it's asymmetrical, in that movements may be happening in one direction, not both. And save that. If you now open up your directory where your UCINET data has been saved, you'll find that there are 2 files for each dataset that you save in UCINET, and these have to stay together. So close down the DL editor, and let's have a look at the network by selecting Data, Display, find your network, set the decimal places to 0, and show zeros as full stop just to make it easier to view, and press OK. This will open in WordPad or Notepad. You may have to do something to the word wrap if it comes in looking like this. It's very hard to view, so select no wrap, and then if we look down the data set, at the very bottom it will tell us that we have 62 rows and 62 columns because there are 62 dolphins. So essentially this is the same edge list, but we have our 62 dolphins going down, and then each dolphin that they've got a contact with, that is listed with a 1 next to it, and we've specified to list the zeros as full stops just so it's easier to view. So here you can see beak. The standard is from are the rows and 2 are the columns. So beak has had a contact with fish and another contact with grin. And if we find feather and gallatin, there's 6 contacts that feather has had with gallatin. If we head down though and find gallatin again, and then look up to where feather is, you'll see that there's nothing listed there. So this is asymmetrical in the sense that feather's done something 6 times to gallatin, but gallatin has not done anything back. Let's close that one down. Now we're going to import again, DL type formats, and this time select Force Symmetry and save this one as Dolphins Sim, which we'll use for most of our analyses. Close that down, and if you have a look at this version, then you will see that there's been quite a lot of changes to the data set. Previously we've had 6 contacts from feather to gallatin. Now we also have 6 contacts from gallatin to feather. So UCINET has just made this into a symmetrical network. So if there's a contact in one direction, it's replicated with a contact in the other direction. The other thing to note is that these are valued. So where there's a 6 or there's a 1, this actually means something. If you have a network that you have dichotomized or turned into binary data, then where there's a 6, that will be made into a 1.